Okay, this is the last few problems from lesson number 25. So recall we were solving exponential and log equations, and I'm just trying to find logs rules. Okay, so when you have an equation where the x is inside the argument of a log, you ask yourself, can I rearrange this to get log of this equals log of that? And if the answer is yes, then you're going to rearrange it. Log of this equals log of that, and you can drop the log. But if the answer is no, then you have to rearrange into log of something equals a number and flip it using the changing to exponent rule. So let's look at this is number 5, part B here. You'll notice we have log base 4 of x plus 6 plus log base 4 of x minus 6 equals 3. Since you have this 3 hanging out, excuse me. So since you have this 3 that's not log stuff, you have to you can't get log of this equals log of that because you have a number. So your goal is to have single log equals a number and then flip it around. So here we're going to use the log rules. So what does plus in between change into if we were going to condense? Well, we would write each one of these, x plus 6, x minus 6, together with timesing, and put both of those inside log base 4. So now we have single log equals a number, and we can now flip it. 4 to the 3 equals these guys. So 4 to the 3 equals x plus 6, x minus 6. Now there's a couple things we can simplify. On the left, 4 cubed, 4 times 4 times 4 makes 64. And on the right, we should FOIL those out because the only time a double bubble is helpful is if we have equals 0. And we don't have equals 0, we have equals 64. So we have to get rid of our double bubble. Now this is a conjugate pair, x plus 6, x minus 6. So when you FOIL it out, x plus 6, x minus 6, you get x squared plus 6x minus 6x minus 36, and the 6x and minus 6x cancel out. So we just get x squared minus 36. So now we're at the task of solving this equation, and what's nice about this equation is we only have x squared. We do not have x squared and also x, which means that we can just isolate x squared, throw on a square root, but also a plus or minus. So I'm going to move the 36 to get x squared alone. So I have 100 equals x squared. And now to kill a squared, we square root. But when you do that, you have to tack on plus or minus. So we'll go all the way over here. So plus or minus the square root of 100 equals x. But I could do the square root of 100, that's 10. So I have plus or minus 10 equals x. So that tells me x equals 10, x equals negative 10. But now, because the log function has a jacked up domain, we have to check our answers. So let's go back to our original equation over here. And I'm really just going to check that when I plug in this x value, it makes the argument positive. So here I have log base 4 of 10 plus 6. And 10 plus 6 is positive. So that's cool. And then I have log base 4 of 10 minus 6. And again, all I'm checking for is that this inside, the thing I'm taking the log of, is positive. So I could go through and do the actual math. What is 10 plus 6? What is 10 minus 6? Take the logs of those numbers, add them together, and see if it makes 3. But I'm going to kind of stop short. I'm going to say, okay, when I plug in x equals 10, both arguments are positive, so I'm probably on the right track. Now let's try x equals negative 10. So I have log base 4 of negative 10 plus 6 plus log base 4 of negative 10 minus 6. And that I don't like because negative 10 plus 6 is a negative number, and you can't take the log of a negative. So negative 10 didn't work. And again, it's not because negative 10 is a negative number. It's because when you plug negative 10 in for your x, you get a log of a negative number. So now let's look again at some more problems, and we're going to decide, can we make it log equals log, or do we have to have log equals number? Okay, so let's look at 6a here. Log base 5 of 11x minus 40, subtract log base 5 of x equals log base 5 of x plus 24. So you may be thinking, hey, everything has a log. So I want you to write down right now that you can't just cancel all the LOGs, okay? The only time you're allowed to cancel LOG is when you have single log equals single log. Now on this right-hand side, this is a single log, so that's cool. But over here, there's 2 logs. This is a double. So I have to say that I don't have single log equals single log. But do I have any numbers hanging out? Like, is there a plus a million outside or a timesing by 2? No, there's nothing happening outside these logs. It's log of something minus log of something else equals log of something else. There's no additional like adding or subtracting, and so I can force it into single log equals single log, but I'm going to have to use a rule to get rid of a double log. So think back in your brains, what does subtraction turn into? Well, subtraction turns into division. So I have 11x minus 40 over x. And I'm going to wrap that up, and on the outside, I'm going to write log base 5. And I'll keep the other side as log base 5 of x plus 24. Now we have a single log on the left, right? Log of something, that's a single, equals log of something else, that's a single. So I have single log equals single log. Now I can drop the LOGs. So I have 11x minus 40 over x equals x plus 24. Now, how are we going to solve this equation? Because there's a fraction. what we're going to do is we're going to times both sides by the LCD. Now, technically, this right-hand side is just over 1, so you don't have a bottom to consider. We're still going to times both sides by x over 1 because I want the x on top to cancel with the x on bottom. So on the left-hand side, it does cancel, 11x minus 40, but on the right-hand side, it doesn't cancel. So I actually have to do this x times x plus 24, which will distribute, and I get x squared plus 24x. Now, what kind of equation is this? This is quadratic. And then there's lots of ways to solve a quadratic equation, but two of the best ways are factoring or quadratic formula, both of which start with 0 on one side. So I need to get 0 on one side. I'm going to subtract 11x, and I'm going to plus 40. That gives me 0 equals x squared plus 24x minus 11x makes 13x, and then plus 40. So now, can I double bubble this? Can I find two numbers that times together to equal positive 40, so two pluses or two minuses, but add up to positive 13? And I think I can. I think that's 8 and 5. So x plus 8, x plus 5. And now we have to set each bubble equal to 0. So x plus 8 equals 0, meaning x equals negative 8. Or x plus 5 equals 0, meaning x equals negative 5. So now if I found an answer, here it is, but I have to go back. And the trick here is that you don't just go back one or two steps. You go back to the beginning. Double logs on one side, single logs on the other. So let's plug in x equals negative 8. If I plug that in, I get log base 5 of 11 times negative 8 minus 40. And then there's some more that are going to go in. Log, let me zoom out a little bit here. Log, base 5 of negative 8 equals log base 5 of negative 8 plus 24. Now, some of you can already see that this isn't going to work. But if we do some math here, 11 times negative 8 is negative 88. Minus 40, this is a negative number. So right away, I have log base 5 of a negative number, which makes the whole thing bad. X equals 8 is not a good answer. Let's try x equals negative 5. So I have log base 5 of 11 times negative 5 minus 40 minus log base 5 of negative 5 equals log base 5 of negative 5 plus 24. So now, again, in this first log, negative 5 times 11 is negative 55. Minus 40 is a negative number. So since I can't use that for that log, I can't use it at all. And I say, oh man, both of my options, like that's not an answer. Since nothing worked, there's no solution. Okay, let's try again. So in part B, I have natural log of x plus natural log of x minus 2 equals natural log of 4x minus 5. So I say, okay, there's nothing here that is hanging out. There's nothing that has just a single log, or nothing that has no log, right? Like a plus a million or minus 10. I can't drop the logs because on this side there's double, right? There's 2 logs, even though on this side there's just 1 single log. So what I need to do is use a log rule to connect these 2 logs to condense them into 1. So remember, the plus in between logs tells me to times. So I have natural log of x times x minus 2. So I'm just going to go ahead and distribute that. X squared minus 2x. So I times x and x minus 2. And that's going to equal natural log of 4x minus 5. And now, like a miracle, I've got a single log on one side equals a single log on the other. And since it's single log equals single log, now we can drop the ln, or the natural log in this case. And I have x squared minus 2x equals 4x minus 5. Now, what kind of equation is this? I see an x squared, so I know this is a quadratic equation. And to solve a quadratic equation, the best start is to have 0 on one side. So I'm going to minus 4x, and I'm going to plus 5. So I have x squared, and then minus 4x minus 2x, that makes minus 6x, plus 5 equals 0. Excuse me. And can I double bubble this? Are there 2 numbers that times to positive 5, so either a double plus or double minus, that also add up to negative 6? Well, that would be subtract 5, subtract 1. If I times those 2 numbers, it makes positive 5. If I add those 2 numbers, it makes negative 6. So I'll set each bubble equal to 0. So I have x minus 5 equals 0, meaning x equals 5. And x minus 1 equals 0, meaning x equals 1. Now we have to check those. So let's go back. X equals 5. So we're going to plug this in to the OG, the original equation. So I have natural log of 5 plus natural log of 5 minus 2. Well, those both look good, right? That guy's positive, log of 5. That guy's positive, log of 3. So that's looking good. Let's check the other side. Natural log of 4 times 5 minus 5. So that would be 20 minus 5. Oh, and hey, that's positive 2. Booyah. X equals 5 looks good. If you want to make sure, then you go all the way. Let's check x equals 1. So I'm going to go back. I have the natural log of 1. Looking good, that's positive, that's cool. Plus the natural log of 1 minus 2. Oh no, 1 minus 2, that's a negative number. And we can't take the log of a negative, so I'm just going to stop and I'm going to be like, hey, sorry, 1's not an answer. So this guy only has one solution, x equals 5.